Okay, great. Officially, you're welcome to another session of our PLD discussion. And today in this discussion, we are looking at the practical use of pointers. So in our prior session, we have discussed pointers and arrays, but we want to see how these are done practically. When we go to the code editor, how should pointers be used and what is the general use of these pointers that we keep talking about? So initially, when you are reading about pointers, it looks like they make no sense. Because if I can access what I can access without them, why do I even bother myself getting them? But from our previous session, which the video is already available, I mean, when we discuss pointers, the video is available on YouTube, so you can get to watch it if you haven't watched it yet. We've discussed the importance of knowing about pointers, okay? So today, let's just drive straight in there and using examples. So the first thing we want to do is go ahead and declare some variables. Let's declare variables, 3 variables for data. For those of you joining us today to get to know that this is actually a repeat session. We had a session last 2 days. Unfortunately, we were not able to record it. So we are having a repeat session so that we'll get the recording 1 and 2 for the purpose of those who were not able to join us during last 2 days session, okay? So if I make reference to anything, maybe assuming that it's something I thought that you were here, then you can always draw my attention to the fact that you weren't here or you don't understand. Then our rules is that it is a discussion, so you can pause us any time at all during the course of the program and ask a question, make a suggestion, or anything at all that you want to tell the house, you are allowed to tell us. Okay, so what I need us to understand right now is that the moment we declare these variables, okay, what is going to happen is that always, I keep saying this thing and I need you to understand it very well, that the compiler or whatever is going to read and interpret your language, your program, does it from top to bottom. Okay, so as soon as we run this, if we run this, we realize that nothing has actually happened, but behind the scenes, something has happened. It's just that we are not outputting anything to our screen. So to the standard outputs, we are not showing anything. But behind the scene, in the memory of our computer, something has happened. So the question is, what just happened in the memory of our computer? And I've explained that the computer's memory, in this case, we are talking about RAM. The RAM of your computer processes almost everything that you do on your computer. So by running this program, the RAM of my computer is processing what I have written. What have I written? I've declared these variables. So the RAM of my computer is processing these variables. How does it do that? The first thing it does is that it assigns some storage space for these variables that I've created. How do we know that? When it assigns these storage spaces, obviously they are in specific locations on the memory or on the RAM that we are talking about, and hence they have their own addresses. So the address of int A or the address of A will be different from the address of B as well as the address of C. For that matter, even though we are not seeing anything on our screen right now, when we go to our memory, they have specific address for A, specific address for B, and specific address for C. So let's go ahead and print their addresses in C. So for now, our interest is in printing the address. And we all by now should know about the address of symbol, or what we use to represent address of. Okay, so to print the address of A, the address of symbol is the ampersand symbol or sign. So, this, then the name of the variable. That should give us the address of the variable. So let me copy this and do same for the rest. So all I need to do here is to change B and C. So just as I said, after we ran the program in the first place, even though we didn't see anything on our output, what was happening behind the scene was the assignment of addresses to each of these variables. For that matter, if I go to run this program right now, we are going to get the addresses of each of them. So let's try that and see. So these are the addresses for each of them. So the very first one is the address for A, that's the variable A. The second one is the address for B, and this is the address for C. Very important for us to note. Now, these addresses ideally are the things or what we should keep note of. You should take note of to be able to access and use your variables. Ideally. So when we are writing programs in the computer, the ideal thing is for us to always remember the address, but unfortunately we cannot keep the address in memory. For that matter, we brought up the concept, or programmers brought up the concept of pointers, so that the pointers will just keep track of these addresses. You and I do not have to memorize this address. So for instance, if I need to operate on A, in some special cases, I can't just use the variable A. I would have to pick the exact location because I don't want to just go and create a duplicate on it. I want to work on the actual value that was stored in memory, and I'll need the address to do so. But I can't record this thing 0x7FFE51. Even to mention it out is a problem. How more if I have to keep them in memory? Imagine if you have about 100 of these in your program. Are you going to be able to keep them? No. So the simplest way is that you are going to create a special variable, and in this case we call that variable a pointer, because that is just going to store these addresses for you, so that anytime you are looking for anything at all, you can access it using the pointer. So the first thing it was printing the address without pointers. Okay, now let's see how we are able to print the address for each of them using pointers. So let me print a new line. Okay. Then we say printing addresses using pointers. So to be able to use a pointer, just like any ordinary variable, we need to first declare the pointer. Okay, so we need to create the pointer and declare it, assign it to the particular address that we are looking for. Now you know from here that if we want the address of A, then this is the address of A. So first of all, so before we even come to printing, we need to declare and assign the pointers. Okay, how do we declare it? Just like any variable at all, we need to tell it the data type, then the name of the pointer, but there is a special way to tell it to be a pointer. So if I say int, say my pointer name is pointer A, this is pointing to A, but the only way to tell it to be a pointer is to introduce the asterisk before it. Okay, so by introducing an asterisk before it in your declaration, you are saying that this variable should be a pointer. So if I go on to say this is equal to, I want to pass this to the address of A, or I want to pass the address of A to this pointer, then I can do this. So I've assigned the address of A to pointer A. Let me copy this and duplicate it for the rest. This becomes B, this becomes C. Okay, so now we have assigned the addresses of A, B, C. Sorry, I need to change these ones too. We have now assigned the addresses of A, B, C to these pointers respectively. So we can go ahead and print out the pointers. So let me copy this and paste it here. Instead of calling the addresses directly, now I can just go ahead and call pointer A. Know that I want to call the address. I've already assigned an address. When I needed to assign it, I use the asterisk. But when I'm calling it, there's no need for the asterisk because the computer now already knows that this is a pointer. And the pointer holds an address. So if I need the address, the only thing that will make sure that we are printing out an address is the format specifier here. Always remember that the format specifier P is used for printing out addresses. So if you want to operate on addresses, then you have to use this format specifier. So let's go on and change these ones as well. Great. If we run this program, hopefully this address for A should be the same as this. Then address for B should be the same as address for B here. Address for C should be the same as address for C. And you can see that that is exactly what we are getting in our case. This tells us that our pointer is indeed pointing directly to the addresses. The next thing I want to do is, instead of just declaring these variables, I want to assign them to values. So let's assign these to values. Say this is 15. With the help of these addresses, we should also be able to access the values anytime we want. If you cannot access the values, then it's irrelevant working with the addresses. An address, just as we all know right now, if when my senior man was coming here, I gave him my address and he had to follow my address to get here. When he got here, he found me. So that's what happens. When you pass an address to anyone at all, or when you have the address to anything at all, you can follow the address to get the exact thing that is being kept in that address. So the only reason why pointers are important to us is because they help us locate what exactly is stored in that specific location of your computer's memory. So then, how do we get the exact value? Now we know how to get the address for the specific pointer, or the address that the pointer is pointing to, by just calling the name of the pointer. But how do we get the value? So to get a value, the process of following an address to get its value or uncovering the address is known as dereferencing. So when we are talking about the addresses, when we say you are following the address, the technical term is referencing. When you are referencing, it means you are getting to the address. But when I go to the address and I want to uncover what is in that particular address, the process is dereferencing. Okay, so now we are looking at dereferencing of pointers. All these concepts we have explained in the previous session. Okay, we are just making this practical. So we want to dereference this by helping us or using these pointers to get the values instead of calling out the addresses. Before I do that, let me print out a new line. I think I have a copy here. Copy it. Great. Just for the purpose of those who are joining us for the first time, note that you can pause us at any point in time and ask your questions. All right. So to dereference anything at all, any pointer at all you need to do is preface the asterisk sign to the name of the pointer. So bring the asterisk sign before the name of the pointer. If I do this, it tells my computer that I'm looking for the value in the pointer. What is this pointer actually pointing to? I know it points to a specific address. For now, I'm not interested in the address. I'm interested in the value, the exact value that is in that specific address. So how do I get it? That is what you do with the help of this. So now let's copy this and paste it here. If you go ahead and do this, it's obviously going to give us the addresses. So we know that if we want the value, we should append an asterisk before the name of the pointer. So we'll do that for all of them. But yes, though, if we go ahead and print it, we may not get the exact result we are looking for. I'm tempted to try it. Let me just try it for us. Great. So you see what kind of result we are getting? That is not the result we are looking for. Okay? It's giving us the results. This is interesting. These values are the values here converted into hexadecimals. The values here, so 5 is 0x5, 10 is 0xa, and 15 is 0xf. So these values have been converted to hexadecimals. Why is that so? Anyone to help us? Let me see. Curious minds. Let's see what you think. Why do you think that? Yes.
I think it's format.
Yes. So you might have said, okay, that's good. So I think two people said that. Thank you very much. So because of the format specifier, we have specified that the outcome should be in form of addresses. And we all know that addresses are expressed in hexadecimals. So all that this line is doing, it went to actually grab the value that we are looking at for. But the format specifier says that specify this value in hexadecimals. So it went out to print it in hexadecimals. But that's not what we are interested in. The values we are looking for are actually integers. So we need to tell our print statement that we want it printed out as integers, which we can do using I or D. Any of them should work for us. So either I or D, you can choose them. Then run this. When we run it, we get our 5, 10, 15. Yes. Goodness, do you have a question for us? All right, so far, any questions so far? If seeing how we get the addresses using without the pointers, how we actually get the addresses. Then with the help of the pointers to how we can get the addresses. Then with the help of the pointers, how we can get the actual values with the help of pointers. Yes, any questions regarding that? Okay. So once we don't have a question with that, I want to presume everyone here understands them. So now, what we can go ahead to do is do some operations with our pointers. And I think that's where majority of the people get confused. Operations on pointers. And this shouldn't be confusing, though we need to understand certain things. So for those of you who were here yesterday, I kept making reference to the fact that you should go and read on operator precedence. And that is where the challenge is. But anyway, let's go ahead and try some things out. So all we should remember when we come to doing some arithmetic operations on pointers is the fact that whether you are using, let's use A for instance. So pointer A and pointer A. These two have different meanings. Very important. So we need to know them so that you know which of them is being used at any point in time. Is it the name of the pointer or the name of the pointer preceded with an asterisk? Very important. That is all you need to know before you can do your arithmetic operations. Okay, so if I'm going to do some form of addition, assuming I want to add, so let's say the first operation I want to do is add, let's say 5 to it. Add 5 to it. The question is, are we adding 5 to this or that? So A, let's say A is for us to add 5 to it, to this. Sorry. Then B. Is someone trying to ask the questions? Yes. I think someone unmuted. Okay. So for A, we are adding it to this. And you should all remember that without the asterisk, this is making reference to the address. It's making reference to the address. When the asterisk comes in, we have dereferenced it. So we are looking at the actual value. So let's solve A. To add 5 to PTA, that would be something like, okay, so let's go out and print it. Try printing addition of 5 to PTA. But before I run the program for you to see the outcome, I'd want someone to tell us what the value is expected to be. So what do we expect the value here to be? And do you find any problem with this line? Yes. What value should we expect? And do we find a problem with that?
I think the value, you get an error anyway, because the pointer to A should be dereferenced.
I think you may not get an error, but you may actually be adding the address. You may be adding since it's an integer, it may be adding about 4 bytes of 5 to 8.
Okay.
That's what I think
okay.
to be added to the address.
Okay. All right. Thank you very much. Great. So before I even go ahead to print it, for the purpose of those who are just joining us who were not here yesterday, let me try and explain this. That's what she said, but let me break it down before we even get to adding 5. So what I need you to understand is that when we take any of these addresses, okay, if you add, say, 1, if you add 1 to an address, this, as you are seeing, is 1. But when it gets into your computer's memory, it doesn't see it as 1. It sees it as 1 integer, because currently you are dealing with integers. If it was a character, it will see it as 1 character. If it was a float, it will see it as 1 float. So all that is telling your memory is that give me enough space for 1 character. Give me enough space for 1 integer. Give me enough space for 1 float. Okay, so it's not just 1 that is going to add to the address, but rather the space that 1 character, 1 integer, 1 float will take. And we have learned previously that 1 character, for the purpose of our discussion, will always be 1 byte. Then 1 integer, for the purpose of our discussion, will be 4 bytes. 1 float, for the purpose of our discussion, will be 4 bytes. Then 1 double. Those are the common ones that we tend to work with. So we stick to these, will be 8 bytes. This means that anytime you have an address plus 1, your computer is first going to check, is it a character you are adding? If it is a character, it's going to add 1 byte to it. So remember that this that you are seeing, even though we are saying it's an address and you see it as such, it's actually a value, but this value is in hexadecimals and it's in bytes. That's what you should know. So this is a specific value in bytes. If you want, you can copy this and paste it in Google and convert it to decimals. You will see the exact value in our normal numerals that we know. But this is hexadecimals, and that's how they are expressed. So by adding 1, if it is a character, it's just going to add 1 character to this. So the last digit here will change to 5 if it was a character. But if it is an integer, then we are adding 4 bytes. If you add 4 bytes to this, then it's going to change to 8. Okay? If it is a float, that will also add 4 bytes. But if it is a double, it will add 8 bytes. So anytime you add anything more than 1, it's just the number times. So if I add 2 characters, it's 2 times 1 byte. Okay, that's what we are going to have. If I decide to add 2 characters, it will be 1 byte times 2. If I add 4 integers, what I'm going to get is 4 bytes times 2. Sorry, times 4. If 4 bytes, if 4 integers. If I decide to add 12 floats, then I'll get 4 bytes times 12. If I decide to add 2 double, then it will be 8 bytes times 2. Okay, and obviously this will be equal to 2 bytes. So your computer will add 2 bytes space, or it will add it to your address so that you get the value this plus 2. In this case, we are going to get 4 times 4, which is 16, and the same will happen for all of them. Any questions on that concept? Any questions on that concept? Please note that a lot of the people here have participated already. So if you are new here and you don't understand, they probably do understand. So don't follow the crowd and not ask your questions. It's the more reason why we are here. So if you have questions, just go ahead and ask your questions. Now that we understand this concept, we should be able to do this. To interpret this print statement, this percentage P is telling us that we are going to print out an address in the hexadecimal format. Then when we get here, PTA is telling us that we are pointing to the address of A. Then we are adding 5 to that address. So from this case, this is the address of A, and we are adding 5 to it. This doesn't mean we are just going to add 5 to this and make it 9. No, but it rather means we are adding 5 integers because A was declared to be an integer. So if A was declared to be an integer, then we are adding 5. We are adding 5 times 4 bytes to A, or to the address of A, I meant. That's what we're actually doing. 5 times 4 bytes to the address of A. The reason it is so is because we decided to add 5, but this 5 is representing 5 integers, and each integer takes up 4 byte space. So if you have 5 of them, it is 5 times 4, that is 20 bytes. So we are going to add 20 bytes to this address. So now let me go ahead and print it so that we see. And those who were here yesterday know this, but let me mention it. Remember that anytime you refresh this, when you have written your program and you have yet to run your program, the computer doesn't associate it with any form of memory. So the fact that you wrote int A is equal to 5 doesn't mean the computer automatically assigns memory to A. It is until you run it. So the moment you run your program, the computer then processes it and allocates spaces for every variable you declare, every function you create, every array you create. All those things that you'll be creating, the computer will automatically assign spaces for them. It is only when you run it. The moment the program is over, everything is over, every memory that was kept is wiped off. That is why you can have just 2 gig of RAM and still be using it to run multiple programs at a time, because your computer doesn't keep them forever. We are talking about RAM. Please don't forget that it is the RAM, not your normal storage device, not the hard disk you are using, not the SSD you are using, not the pen drive you are using. No, it's the RAM. And on the RAM, it is during the process that is running. So if you are using a Windows machine, you can always check your task bar or task manager. You can check your task manager and you get to see all the processes that are running currently. So if any process that is running, it means that at that point in time, when you go to your computer's memory, there is space allocated for it. The moment you kill any task, you have wiped off that storage. Okay, so if we want to run our program, As soon as we run it, all of these will be created. The storage spaces, addresses will be assigned. But the moment our program is over, they will be cleared. Reason why I came to say this is because you are seeing this address and you may think that when I run the program, it should automatically add the 20 bytes to this same address. But the interesting thing is that if I should run this again, all this will be wiped off and new addresses will be assigned. So one problem we had yesterday that someone brought up was they were trying to replicate what I was doing here, but they weren't getting the addresses that I was getting. And the reason is that we can't get the same address even on my own computer when I run it again. The moment you run it, your computer decides where to assign it. Your computer automatically decides which address to assign to your pointer or to the variable that you have created. For that matter, I'm going to refresh it and it's going to change. But we know that after changing whatever value that we get, the A will just take note of A address. And when we come down here, we are going to get 20 bytes added to the address of A because we have added 5. So for now, let me comment out everything relating to B and C so that we only have things relating to A. Comment out B and C. Okay. B and C. Let's comment you out. All right, so hopefully I've commented out everything relating to B and C. Let me pass a new line here. Run the program. Great. So let's see. All right, this is good. So the first one we have here, this address is the address of A. Okay, so when we go through our code, we see that we printed address of A here. That's the first one that we can see. Then down here to a printed address of A using pointer A. So we printed it here. That is what is here. Then this 5, I think, okay, we printed out the value that A was containing, and that is what is giving us this 5. Then finally, we added 5 to A. So this is the plus 5 that you are seeing. And we said the plus 5 is actually plus 20. So this expression here, plus 20, is what is giving us this. If you want to test it out, you can, let's see, let me try this. I'm always curious about things. So you just come to Google. Google is a good calculator. Then you do this minus that is equal to this. Then you run it. It's 14. How is that 14? Okay, so the difference is actually 14, and I'm interested in why it's 14. Let's add 1, then try and see. So this C, unless if my computer is no longer recording integers as 4 bytes. Let's see this. It's 4. So why? So for those of you who are interested in what I'm just doing, this is how you learn some of these things, okay? Anytime, I think yesterday or last 2 days, there was a question that I had to explain how I came about it. Okay, so this is what I usually do. So we've seen that the difference when I added 1 was 4 bytes. Now let's add 2. Then we can go back and check the difference between this and that. Because it's not easy for us. We've not actually been taught the easiest way to be working with hexadecimals. I don't think any mathematics teacher taught me how to work in hexadecimals. So when we use 2 bytes, when we added 2, we are getting 8 bytes. Okay, let's go on. Let's use 3. 3, run 3. I don't know why the 5 gave us 14 instead. So subtract this and subtract it. C is 10 is A, 11 is B, C is 12. So that is 12. That's fine. 12, then 4. 4. Let me copy this first. Minus this. So that should be 16. Oh. Okay. Okay. So I think 16 is more than hexadecimal. So we will calculate as 0 and 1. Yes. Add 1. Okay. Yeah. So I think what's happening is actually the difference in hexadecimals. Because 16, yes, base 16. So 16 cannot be part of base 16. You will run it off as 0 and start again. So the next one will then add 4 to that 1 0 that we got. That makes sense. Okay. So hopefully you should have class okay, that's sorry. Someone called me right now. I'm not where I can use my Wi-Fi. So anytime a call comes through, my network messes up. So sorry for that. All right, but I hope you all get it right now. So whether you add, no matter the amount of number that you are adding, it's just depending on the type of data that you are working with. So if it is a character, we know it's 1 byte. If it is an integer, we are working with 4 bytes and the rest. So in the same vein as we have done with the addition, we can do same with subtraction. So if I go ahead to subtract 1 here right now, and assuming that I've changed this to floats, someone should help me. What do you think should be the outcome? Yes. What should we expect? I've done -1, floats. Explain to me what you think.
You still go with the -4.
Okay, so we are going.
Bytes to contain will be 4 bytes.
Okay, that's good. So we are still working with floats, which is 4 bytes. So for that matter, we are going to get the -4. Let me remove the earpiece. Sorry. Okay, so that is good. Float is still 4 bytes, and we are just subtracting 1. This means that we are actually subtracting -4 bytes from the address that we get. That is excellent. Do I go back in? Okay, so with this, I believe that we can do any addition and subtraction. But now let's take a look at if I had this same thing, but rather in this way. We are still dealing with floats. What should we expect for this line of code? Yes, at least those who were here last 2 days should help us out. What should we expect for this line of code? The line 45.
It has to be value -1, which is the value is 5, right? The addition,
Yeah.
the value assigned, so that would be 4.
Great. So as soon as we brought this dereferencing symbol or the asterisk before the name of the pointer, we have told it that we want the actual value. So go in there and go and look for the specific value that it is pointing to. Then after you have found the value, so this is going to be the actual value. In our case, it's 5.0. So if it is 5.0, your compiler will replace this code with 5.0. So it's as if it didn't see this. It will make it 5.0. Then now you have 5.0 minus 1. So that gives us 4.0. Okay? And that is exactly what we are looking for. Why did they print 0.0? Or we're pointing to the wrong thing. Why? Okay, I know why. So we still told it is an integer here. The pointer was pointing to an integer. So please pay attention here. When I changed it to floats, I forgot to change this pointer declaration to floats. And once it's still integer, it's giving us this problem. We are expecting the 5.0 here, but it's giving us 0.0. And I think in such a circumstance, you are likely to even get segmentation faults, okay, because it's looking for an integer where you're actually storing a float. So that can throw segmentation faults. Okay, so we should always pay attention to that. And as a programmer or a software engineer to be, one thing that we should always look out for, be curious about things. So if you observe, anytime I do something that I'm expecting and I'm not getting it, I want to know why. Okay, that's how you become better at what you do. Anytime something happens, why is this so? I was expecting this, why that? Let's try and find out. So it's only by finding out that you learn. In fact, we learn more from the mistakes that we'll be making. I keep saying that as an experienced software engineer or programmer, what will make you exceptional is the kind of problems you've been able to solve. So if you meet a lot of challenges and you've been able to solve them, when you find yourself in any role or any capacity as a software engineer, no problem is too difficult for you. Like, you should always even have your own procedures that you go about to solve problems. Okay, so let's not run away from problems. Anytime you find something is not working the way you want it, you want to delve deep into it and find why is it not working the way I want it. So now we know that if we correct this to float, hopefully it should give us 5.0 here. Then this 4.0 because we've subtracted 1 from 8. So in summary, let me open a new compiler. In summary, all we've learned is how to use pointers, that is how to declare. So we've learned, or let me write my pen. Okay, so what we have done today is we've learned how to declare pointers. And after declaring a pointer, obviously you want to assign some addresses to it. So how to assign the pointers to, we've looked at it. Okay. All right. So we've also looked at how to assign the values to the pointers. Bring it down here. So that's it. How to assign the pointers. Then we've looked at, after assigning the pointers, we've looked at doing some operations. We've looked at doing some operations to the pointers. Okay. And the basic operations that we've talked about are addition and subtraction. We've talked about addition and subtraction. We've also looked at how to, the operations in terms of whether we are working with the you should test the addresses that we are adding. You know that you should look at the data type. If it is an integer, you know how, yes. If it is an integer, you know how much you are adding. If it is a character, you know how much you're adding, and in that order. Now that we are done with that, there is one special type of arithmetic operation that we need to pay attention to. That is increment and decrement. And I think yesterday, that's what, last 2 days, that's what took majority of the time. Hopefully, today it wouldn't take that much of the time. And I just hope that if you are new here, my guess is that the people who are already here, who were here last 2 days, may understand it. So if you are new here, this particular part that we are going to is for you. Please, and please again, let me repeat myself, because the people who are already here may understand it, they may not bother to ask questions. If you just follow the crowd and refuse to ask questions to understand, then I'm sorry to say, but you'll just be wasting your time. You still need to go back and go and read again. But we are here so that we all understand the concept. So we are going to look at increments and decrements. Yes, Michael.
Before we move ahead, please. Like in
Come
the
again.
before we move ahead, please, I just need a bit of clarification
Yes,
with the address assignments. The example you gave the other time, you said we added 5, so it turned out to be 20 bytes that were adding to that particular address. What
exactly.
if we actually subtracted one from a 4 byte space? Is it that the address will become 0, or will the variable be deleted?
No. So you realize that if we are subtracting 1, the address is never just 4. It is a very long hexadecimal value. So it's going to subtract for the actual address. Okay. So if your address was ending with 4, then when you subtract 4, it's going to now end with 0.
What I mean is a space of 4 bytes now, like we declared an integer is 4 bytes now. So we are trying to subtract 1 from that integer, meaning we are subtracting 4 bytes from the space we initially had. So will the space now become 0 bytes?
Okay, so that is not the case. Yes, I get your question, but that is not the case. So this is how I always interpret it. There is, when we say subtraction, okay, it's actually just movement in here. So this is the memory of our computer. And let me just draw some grids here. Assume we are dealing with integers, okay? So each grid that I'm going to create will represent 4 bytes, just to illustrate your question. Okay, so last one, then through this line. Okay, so let's assume each grade or each box you see is 4 bytes. Okay, so after declaring your integer a is equal to 5, it means that this space from here to here is 4 bytes. Okay, it's 4 bytes. And you are saying that when we subtract 1 from this, one integer, meaning one, that is 4 bytes that we are subtracting. So are we going to get 0? The answer is that no, it's not 0 per se. It's just going to bring us back to this particular location. So it's just about locations. Okay, so the actual address of this is something like 0x7b 778AC48, let's say 4. Okay, so that is the exact address of this space that we are talking about. So after subtracting 4 bytes from it, we have come to all of these. Okay, then 80. We subtracted it. This is the new location. So it's not 0 bytes, as in there is no space again, but rather it has taken us to a different location. And that different location is 4 bytes behind the original location we were. So we're here. This is the location we're looking at. And now we've moved backwards 4 bytes. So we've come to this location. If I decided to add 4 bytes, I would have moved from this location to this place. If you decided to add 20 bytes, so it would have moved from, this is 4 bytes, 8 bytes, 12, 16, 20. So now we are talking about space here. That is what we should always remember. So this is, you can visualize this in your mind. It's more of the location on your computer. There is no way you are going to clear everything. There is always space on your computer to store something. But where are you located on the memory? That's what we are interested in. So your computer will always look for a space where you can occupy. Then put the variable that you have declared, the function you've created, the array you've created, all those things. The computer will look for an empty space and paste them in there. When you begin to do arithmetics on it, you are just moving forward or backwards. If you are adding, you are moving forward, the number of bytes that you added. If you are subtracting, you are moving backwards, the number of bytes you added. But each of the space or location that you get to has its own address. Michael, are you answering?
Yes, I understand now, sir. Thank you.
Thank you. You're welcome. Any other question? All right, so we are about to talk about increments and decrements. Increments and decrements. Very important and interesting discussion that we are going to have, I think. Okay, so by now I know we might have come across this and that. So when you have the double plus sign, that is known as increment. And when you have the double minus sign, that is known as decrements. Okay, so that's what we are going to talk about. And anytime you see plus plus, so if I say A plus plus, what it actually means is that A is equal to A plus 1. That's what the increment means. Sorry, let me increase this. Okay, I hope you can see my screen well. The increment means if A plus plus, it means A is equal to A plus 1. So if on the other hand I had A minus minus, what it means is that A, that's my new A, is equal to the original A minus 1. As simple as that. So the increment symbol means adding 1 to whatever you have. The decrement symbol means subtracting 1 from whatever you had. But always remember, in our case, when we are working with pointers, we need to remember whether it is the addresses. So are you working with the address or the value? Very important. So we've said that if you write a name of a pointer, the name of the pointer could be anything. It could be X. It depends on you or the question that you've been given. If a pointer has been assigned a particular name, say P, then you are going to work with P. So in our case, to make things simple, we are just using this. Okay, so if you are the one who is creating your pointers, it makes a lot of sense to assign pointers that you can easily recognize. So if I write PTA, in my head, anywhere I see this in my program, this is pointer to A. It only tells me that I've created a variable called A, and I'm pointing to it with this variable PTA. Okay, this is not like a standard thing that you must do, but it's something that if you do, it helps you to easily understand the code that you have written. Okay, you are not obliged to name your pointers this way anyway. So what I'm trying to make here is the difference between this and that. This will always point to the address. So this is for address, whilst this is for the value. So if someone is doing an increment, assuming I have given you PTA plus plus, and I've given you PTA plus plus, what you need to know here is that this PTA plus plus is actually adding to address, whilst this PTA plus plus is adding to the value that it points to. For the sake of newcomers, I'm giving you a few seconds to assimilate this. Yes, ask questions. It's very important. I don't know.
Good day.
Yeah, good day.
Good day. Yeah, I just entered. I'm seeing some comments and this invariable declaration, not declaration, variables that you're talking about. So I'm like, I'm trying to relate what you're doing right now. I don't know. Please enlighten me. I don't know what you've done so far. Thank you.
Okay. So it's unfortunate you joined late, but we in this program I'm writing, this is just a note that I'm making. So I'm not writing a program anywhere. We've already done our program explaining things here. So I'm now getting into what we are about to do, and I'm just making notes here. So this isn't any C program that I'm writing. So I haven't declared anything or anything of that nature. Okay, I'm just explaining that when you see, assuming this is a pointer name PTA, if you see this without the asterisk, then we are talking about the address. But once the asterisk comes before the name of the pointer, then we are talking about the value. And I've explained what plus plus is. That is adding one to it. So if I have PTA plus plus, then it means that the one that I'm adding is actually adding one to the address. And asterisk PTA plus plus means I'm adding one to the actual value. So this is just a note that I made to explain things. Yes, any other question?
Thank you. Will there be a recording available for this after you're done?
Yes. Hopefully it is being recorded. Yes. So
last time it was not recorded, and I really did miss out. So I just
yes. So that is even the same reason why we are doing this recording. And before I started the recording, I explained the challenge that I had the last time. It's not, I can't say it's directly my fault because I knew that I was recording it, but unfortunately it didn't record. I wouldn't waste another time to come and do a session I've already done. Okay, so it is not that I intentionally did it, and I made sure that it is recording. Unfortunately, okay, yes, so I can see it has recorded 57 minutes already. Okay, so we are rest assured that this time it is recording. Yes, any question? Any other question? All right, so if there is no question, let's continue. Now, let's deal with our increments and decrements by starting with our integer a, or let's use x this time around. Integer x is equal to 10. Then we want to assign a pointer. Call this pointer tx is equal to address of x. Okay, address of x. So I've said that if I go ahead and I do for this, if let's say I go ahead and print, let's print something. Print address. Then this time around, I'm going to print ptx plus 1, which we have already looked at in the previous session. PTS plus 1. This means that because it's an integer, we are adding 4 bytes to the actual address that we have here. Okay, so maybe I should print out the address of x first. So the pointer itself, let's print out the pointer before we even add. Okay, so sorry, this doesn't need to be there. All right, so if I go ahead and print this, we see that we have added 4 bytes to this to make that. I think C is for 12, 0 is for 16. So 12 plus 4 will give us 16, like 0 and 1 here, 16. That's good. Okay, so we've added 4 by doing this, added 4 bytes because we are dealing with integers, okay? But what I need us to understand is that this plus 1 is actually same as saying ptx plus plus. Okay, but we need to know something to be able to use this. The plus plus, as the increment symbol, has two different ways it can be used. It can be used as a preface or a postface. So we can use the increment or decrement symbol as either a preface or a postface. Very important. Please, once again, those who are not here last 2 days, this part is for you. Very, very important. So what do I mean by this? For instance, we store our pointer PTS. We can have it as plus plus this, or we can have it as PTS plus plus. And even though they all mean the same thing, what I say they mean the same thing is that this implies that our new PTS will be equal to PTX plus 1. Then this will also mean the same thing, PTS plus 1. But in their usage, there is a slight difference. Very subtle difference that we need to pay attention to. That if you don't know the difference, that is when you are going to suffer doing this sort of mathematics. Very important. I'm slowing down so that everyone here would get this. That even though this and that mean the same thing, we are adding 1 to them, they actually have a subtle difference. And the difference is in terms of the operator precedence. So I have given an assignment for every one of us to read on operator precedence. Very important. If you need to do any form of operations in C programming, you need to understand operator precedence. So let's do all to read on it. But I'm just going to explain what happens here. So anytime you are using plus plus this, so the increment symbol before the name of the variable, what happens is that the addition is done automatically. So if, let's say, I say a variable, let's call a new variable y is equal to, if I say y is equal to plus plus ptx, what's actually happening is that this 1 plus ptx will be added. So this side of the operation, this one, it will be done before the assignment to this operator precedence. So when it is a preface, this preface is more important or has higher precedence over the assignment symbol. That means that the computer will first operate on this, finish it before it comes to operate on this. So by writing y is equal to plus plus, when I break it down, what's actually happening is that I have the first thing that it's doing is that PTS is equal to, I've even written it here, so let me just copy it. So that's the first thing it does. We are explaining this. When you have written such code in your C program, what is actually happening is that we have PTS is equal to PTS plus 1. So we'll get the value for this. So say this is your new PTS. We've added 1 to the old PTS and you've gotten a new PTS. Then the second step will now be, okay, y is now equal to the new PTS that we have created. I hope you are all here with me and you are seeing what is happening. By writing this, the plus plus before it gives it a higher precedence. So that operation is done before the assignment operation. So this is the first thing that happens. And after this has happened, the next step is to then go ahead and assign the outcome of this operation to y, because the equal to sign is an assignment sign. However, if we had y is equal to ptx plus plus, then we are looking at a different story where the assignment has a higher precedence over the increments. So what is going to happen is that the first thing that happens here is y is equal to ptx. That's the first thing that happens. Then the next thing that will happen is that PTS, that's our new PTS that we are going to get, is equal to PTS plus 1. So beyond this line, anywhere you use PTS, you have added 1 to it. But before this line, it is not so. So y will be equal to PTS, not the one that you have added 1 to. Please, are we seeing the difference? I really need you to understand these two concepts. Very, very important.
I don't get it though. Please. I'm observing, but I don't get it.
Do you have a specific question to help me explain it better for you? Do you have a specific question?
Okay, you mentioned when y equals plus plus ptx, you say the plus that's the increment value has precedence over the assignment. That's the equal sign.
Yeah.
Okay. So in this sense, if I'm let me imagine a value that y has. Let's say y was 5. So if we are saying that y equals plus ptx, so we are actually saying that we will start from 6. Is it what I mean?
Okay, so let's use a simple example to explain it. So what we have here is x is equal to 5. Okay, then what we are saying is that if we say y is equal to plus plus x, okay, if you say y is equal to plus plus x, if you go ahead and print y, let's print y, which is an integer. So format specifier d, then pass the value of y. So what I'm saying here is that the actual thing that is going to happen is the first thing is that we are going to get x is equal to x plus 1. Okay, that's the first thing. Then the next thing is y is now equal to the new x. So assuming this, if we decide to call this new, x new, then it means y here is equal to x new. That's practically what happened. So we would have added a 1 to this before assigning it to y. So if I go ahead and print this, sorry, where do I have a problem? Did I not comment? Oh, I didn't declare. I've not even declared y2 and y. Okay. So it's giving us 6. Okay. But unlike this, if I go ahead and let me comment this line out, then create a new one. Say y is equal to x plus plus. Hey, why are you commenting? X plus plus. So this is a different thing from this. And what is happening here is that in this case, the y is equal to x has the precedence. So we are going to first assign this x value, which is 5, to y before we even do the operation. So we are going to get y is equal to x. Then the next thing, this should be commented. Oh, comments. Then the next step will be now x is equal to x plus 1. Okay, so I could decide to call this x new just for demonstration purposes. So this our y is giving us the original value. Let's run this and see. Already you know that you are adding 1 to x, but when you run this, your y is still 5.
Okay.
The reason why your y is still 5 is because when you run it, the first thing it does is the assignment. So that's why I said we should all go and read on operator precedence. The first thing it does is the assignment. And after the assignment, that is when it does the x is equal to x plus 1. So if you go on to now print x is no longer 5. Even though y is giving you 5, x is now 6. Because beyond this assignment, there was an increment. So let's go and run this, and you see x is 6.
Uh-oh.
Is it confusing? It shouldn't confuse you. See, so yesterday, guy, relax. Let me say this before we continue. So yesterday, this is what I said. The last 2 days, this is what I said. That when you and I were growing up in nursery or kindergarten, they told us that when you have 1 plus 1, it is equal to 2. We kept it in our head. And now we all know that 1 plus 1 is equal to 2. It is the same thing here. Anytime you have your plus plus coming before the variable, you have to add it to it for the first operation. So in this case, our first operation is y is equal to plus plus x. So the outcome we give there is going to be plus x, like plus 1, we would have added 1. But if it is after, then in the first instance, don't add it. So even though we are doing y is equal to x plus plus, we are not going to add a 1 to this. It's like it does that assignment before it does the addition. So just keep in your head, anytime the xs comes, the plus plus comes before it, it means that you have to add your 1 to it. If it comes after it, then your first thing that you are doing, don't add 1 to it. If you are doing another one, then you add your 1 to it.
All right, thank you.
Welcome.
The thing is that you actually printed for x in this expression y equals x plus plus. You didn't try it for in the first one where y equals plus plus x.
No problem. We can always try it. So let me uncomment this. If we print this, this is also going to give us x is equal to 6 because already we have updated. X is now a new number, so it's going to be 6. Okay, so when you run, you are going to get 6, 6. So just keep this in mind. If it comes before it, like you've already added the 1. If it comes after it, the first thing you've not added the 1. So the very first line, that is in this case, y is equal to x, the 1 is not added.
So if I may say, in the case of this expression, it affects the x, it affects the y, not the x. But the increment, the y equals plus plus x, and in the case of y equals x plus plus. So if you are printing the value of x, the x is will actually be incremented, but for the y, there will be a change. There will be some kind of precedence going on there when you want to print the y. That's what I understand now. Because both cases, they will print, in both cases of x plus plus x and x plus plus, if you print x, the value will be 6. But for y, it won't be 6.
Yeah, so that's what precedence we are talking about. So when we are talking about precedence, we are looking at just the operators. Here we have 2 different types of operators. We have assignment operator and we have increment operator. So which one is more important? That's what precedence basically means. Which of these is more important? And we are saying that anytime the plus plus comes before the variable, then we say that the plus plus is more important than the equal to. So this will be evaluated. The right-hand side will be evaluated. But in this case, the plus plus is less important than the equal to. So the left-hand side will be evaluated.
Yes, I get it. Thank you very much. Yeah.
You're welcome. Any other question? I need to do another example to clarify this whole thing. Any other question? Haruna, you are going to say something. Are you there?
Yeah, I'm now clear.
Oh, okay. That's cool. So yesterday, I think I did an example. If x is equal to 2, or I did something like this, 2. Okay. Then I say we are going to print something. While x is less than 3. Okay. While x is less than 3, print f of integer, then n pass the value of x. Okay. So if I run this program will continue running without terminating because there is no increment. But assuming we have this is where the difference comes in. So let me try using this to explain what we just did over there. And assuming this is plus plus x. These two will give us different results. And that's what I need us to understand. These two will give us two different results or outcomes. The difference is that in this case, please pay attention. In this case, when we are looking at precedence, because you put the increment symbol after x, it has less precedence. So it means that this less than sign is more important. So the very first thing that your program is going to do is going to check if x is less than 3. That's the first thing it's going to check. And after it has done that, it will now do x plus plus. Giving you some seconds to assimilate it. Please, we need to understand this before we send increment and decrement to pointers. It's a bit confusing, so I need you guys to understand it, please.
Okay,
Yes.
here, and I did y equal to x plus plus, and my value for x is 10. So when I print it, gave me only 10.
When you printed what?
When I printed the y, it gave me only 10. It's going to add the 11 to.
You said you did x plus plus.
Yeah.
So yes,
The
it will
value
give
for
you.
x is 10.
It's not
So
any different for this. This is what you did, this line.
Yeah.
And I said that on this line, it's first going to execute y is equal to x. And you said your x value is 10. So it's going to give you y is equal to 10. Before it even comes here to do 10 plus 1 to give x to be 11.
So when will it do that 11? Give me that 11.
It has done it. It has done it, but it is not equal to y. So if you go ahead and print the value of x has changed. That's why I keep putting new here. X has now changed, but y hasn't changed because y is equal to x, the first x. Please understand this. When you have anything of this sort, your operation does not operate like it doesn't occur in just one sequence. There are 2 steps. So the question is, which steps happens first? That's what will give you the outcome you are looking for. Which step happens first? So if you have the operation y is equal to plus plus x, we are asking ourselves, which step will happen first? And you realize that, the plus plus x has the precedence in this case. So we are going to assign a new value to x before we even go to the assignment. So by the time we get to the assignment, the value of x has already changed. So in that case, y will become the new value of x. But in the second instance, where we have y is equal to x plus plus, in this case, the assignment has a higher precedence. Once it has a higher precedence, your computer is going to run the program from left to right. So it's going to be x is equal to y is equal to x. That's the first thing it did. Y is equal to x. It is done. That step is done. The next step is x plus plus. So that is where it gets x is now equal to x plus 1. Let me go ahead and interpret this. Okay, so I'm saying that in any case when you find your plus plus, the increment or decrement, I keep using the increment, but it's the same for the decrement as well. So when you use the plus plus anywhere, what is happening is that you have to break it down into 2 steps. It's no longer a single step evaluation. It's 2 steps. The first step you have to ask yourself, is the plus plus before or after? If it is before, then it means the plus plus will be evaluated first before any other thing. If it is after, then every other thing will be executed before the plus plus. So in this particular case, x plus plus is less than 3. Because the plus plus is after, it means x less than 3 will be executed first before we now increment the value of x. If you come to this other line, where we have plus plus x less than 3, what it means that a new x will be assigned to be x plus 1. That will be the first step. Before now, we use this new x that we have gotten. So let me append new here. Sorry. Put new here. This new x that we have gotten will now become, so x new will now be compared to 3 and find out if it is less than 3. So let's make this practical. You know that x is 2 here. So in our case, when we run this program, while x plus less than 3, the first line is going to check, is 2 less than 3? 2 is less than 3. So if 2 is less than 3, go ahead and print x. But the moment it does, if 2 is less than 3, the next thing, x has been incremented. So now we have 2 plus, so that is 3. So now x is actually equal to 3. Even though in the first instance, it checked if x, which was originally 2. So if 2 was less than 3, yes. But by the time it gets here, x has already changed to 3. So it's going to print 3 here. Let me go ahead and run it for you to see the outcome. Seeing is believing, they say. So let's run it. So you see, it prints out 3 for us, but it doesn't continue again, because by the time it comes back to the while loop, x is now already 3. Okay, so the first instance, it was able to come in here to come and print x, because x was 2. And if 2 is less than 3, we should print this. So he came in here to come and print it. But by the time he got here, he said, let's print x. X has actually been incremented to 3. So when it prints 3. Let's run this second while loop and see the difference. When we run this second while loop, what is happening is that the first line is going to do the addition here. It's going to check plus 1 with x. So x is 2 plus 1 is 3. So it's going to check if 3 is less than 3. And the new value of x is 3. But 3 is not less than 3. So this line will not even be executed. That means that even though these two while statements are similar, because of the difference in usage, the postface and the preface, they give us different outcomes. If I run this program, no outcome, because it doesn't get into this part. This already evaluates to 3, and 3 is not less than 3, so it doesn't print this. Questions? Please, I need us to understand this before we continue.
Okay, no. So when you run it, it will first read the while before coming to the printf.
What are you talking about?
You saw while bracket of n plus x less than 3. So when you run it, it will check is x less than this and 3. So here, because the plus is coming before the x, is equal to 3. It's not less than it, so it will not come to print f. That you should print x, but because it's equal to 3, it won't print anything.
Exactly. Yes. Any other? Please, I'm waiting for you. We need to understand this before we move on. Any other? Everyone understands? Please, does everyone understand it? Hey, or you guys are not here?
I understand.
Just for educational purposes, can you change the 3 in the while loop to a 5 maybe, so it will print out something in the second one?
Okay. All right, so.
Hello.
So let's try it with the first line. Yes.
Also,
yes.
We have been doing for plus. Can we try minus? Because I think this in minus 2 will
yes, it's the same thing. So, all right, we'll do that. It's the same thing. That's why I just want us to understand. Once we understand, we can implement it on anything we want. Okay. So for now, let's do this. We'll do an example with plus. That is what someone requested. Okay. So what is happening here is that we now have while x plus plus is less than 5. Okay, so I've told you that anytime you see plus plus here, just know that it's going to occur in two sequence. Depending on whether it is before, that is preface, or postface. So in our case here, it is a postface. And if it is postface, what happens is that it is giving less precedence, like it's less important. So the first step ignores it and goes straight. It's as if this didn't exist. So that's the first step. It check if s is less than 5. And s in this particular case, s is equal to 2. So what this is actually checking is if 2 is less than 5. Then afterwards, after immediately this has been evaluated. Now the condition has already been evaluated. So we no longer have this. It has already been evaluated. The next part of the equation is to do x plus plus. So just say x is equal to x plus 1. That is what is happening. So always remember that it evaluates in two steps. Okay. So the first step, once you find the most important, whether it is before or after. In this case, it is after. So the first step, it is not important. We do the first step. Once we are done with the first step, this is also gone. All we are left with is the plus plus to work with. Okay, then x plus plus means we should add 1 to x. X was originally 2. So now our x becomes 3. So before we enter the loop itself, we have this. We check that x, which is 2, is less than 5. Then afterwards, our x, we are adding 1 to it. So our x now becomes 3. That is before we enter the loop. So once we've entered the loop, it means that in the first place, we are going to print out what? 3 for our x. Our x here will not be 2. Because even before we enter the loop, we had added 1 to it. So it will be 3. Then now x is 3. So we'll come back to this while loop again. Then we'll come and check 3 being here. So now we'll also ignore the plus plus and do is 3 less than 5. If 3 is less than 5, the next thing we'll do is now x that is 3, let's add 1 to it. So our x now becomes 4. So go ahead, you print 4 here. Bring the 4 back to the loop. Then now we have 4. We'll ignore the plus plus because it has less precedence. So we do 4 less than 5. If 4 is less than 5, now ignore this and do 4 plus plus. So our 4 here, our x now becomes 5. But this is 4 less than 5. Okay, so that is how it works. This will then enter. Now this is already 5. So if it comes in here, we will now have 5 less than 5. 5 is already less than 5. Okay, and x plus plus. 5 is less than 5. So that is not going to work. We can't enter this again. Okay, so let's print this for you to see. It started by printing 3, 4, 5. Okay, 3, 4, 5. And let's run this. I think I've explained how we are able to get this 3, 4, 5 already. When we comment this out and we come to this line of code, what's happening is that originally our x is 2. But before we even get here, it has been added. So now we have 3 entering this loop. So this loop is 2 plus 1. That is 3 before we even come and check. So 3 less than 5. So we'll have this being 3. And our x, which is 3, will also be less than 5. We are looking at 5. 3 will be less than 5. So we'll come in here and print 3. So this will be printed as 3. Then we'll now bring our 3 in here. Plus plus. So 3 plus 1 becomes 4. So now we are checking if 4 is less than 5, which it is. So our x value is 4. If 4 is less than 5, so we'll go ahead and print it. We'll print 4, okay, as the value here. Then now the next step, we are coming in here, we are checking If 4 plus 4, that is 5. Is 5 less than this? No. So we can't come in here to print the 5. So that is where the difference comes in. If you are printing X, I hope every other thing is correct. Okay. So when we run this gives us 3, 5, and does not print the 5 that we had here. Maybe I should run both of them alongside. Put a break before them. So print an empty line. Print f of, okay, and run this. Oh, did I comment the first one? Why?
You may have to change the first one.
Oh,
to
okay,
Y
okay, yeah. I have to change the variable. I have to change the variable. So let's create a new variable called y. Thank you very much. And assign the same value to it. Then use that for the second loop. This is funny. Okay. Let me remove the comments here. Okay, so hopefully these are the same codes that would have expected the same result, but the difference is the position of the increment. Yes, any questions? Please, we need to understand this thing. In summary, all that we have said is that anywhere you see plus plus or minus minus, you know that the equation, the expression, the statement, however you call it, will be evaluated in 2 steps. Anywhere you see plus plus or minus minus, okay, you are evaluating your equation in 2 steps. How you do that is first check which one has precedence, which one has the highest precedence. Okay, so if we have the increment symbol coming before the variable, then what you have to do is that add the 1 to the variable. So add 1 to variable before you do any other thing. Do we get it? So if we had, in our case where we had plus x less than 3, what this tells us that we should add 1 to this x, which was 2. We should add 1 to it even before we do any other thing by checking. However, if this comes after, so let's keep using the plus for consistency's sake, after the variable, then we should do the operation. So do the operation, and after you are done, add 1 to the variable after you are done. Does this clarify it? Please, let's just keep it in our heads. Anytime you see an increment or decrement sign, we are going to run the equation or the statement in 2 steps. If it is before, that's the preface, then automatically add 1 to the variable before you do any other operation. If it is rather a postface, then you want to do the operation before you add 1 to the variable. Please, do you get it? Questions? We want to move on to pointers, using the increment and decrement symbol with pointers. But I need us to understand this so that it doesn't become confusing when we get to pointers. Yes. So I should presume everyone here understands it. Okay. Now let's get to pointers. Which one? Okay, we're using this one. Great. So this, I want someone to tell me what's going to happen if I decide to print, let's delete this. Yes. Someone should unmute and tell us, what do you think we are going to print out? Explain why you say so. Would this value be the same as this? Or will it be the same as this? Explain your thinking behind it. Yes.
Let me get it very clear. We are comparing number 16 with number 12 and 13, right?
Yes. Or better still, you can just take number 16 and tell us what you think about it. Explain what is going to happen with that statement.
Okay, you mentioned about increment with by value and increment by the incrementing value, incrementing address, and when you have and when it's in this position now, we are actually going to be incrementing address.
Good.
Incrementing address, yeah, that's what's going to happen here. We're incrementing address by 1.
Okay.
Yeah.
So that's the first. Yes.
Yeah.
Continue.
So if a pointer came before it, then we'll be actually incrementing the value by 1, the value in the address by 1.
Okay. But with the location of the plus, what does that also tell us?
With the location of the plus, it's going to tell us that we will first of all take a note of the position where the variable is before we make an increment. All right, we take the precedence will be the address at the given point before we make an increment. We take note of the address.
So if we print it, is it going to print the original address or the one that we have added the 4 bytes to?
It will print the original address.
Okay, why do you say so?
So before when it comes to the distance, it will first print the because the plus is after the pointer x, so it will print the old one before going to print the new one.
Okay, thank you very much. Okay, all right. So that is how we introduce our pointers and increment and decrement to pointers. So if we have a pointer called pointer x, as we have in our case, if you have anything to do with it, the first thing you need to know is, are we working with the address? That is in terms of pointers, or are we working with the value? And by now we know that for us to work with a value, we should have dereferenced it with the asterisk. Okay, so that's the first thing you want to check, whether your increment or decrement is supposed to be with the address or the value itself. Once you have done that, the next thing is to look at the decrement or increment. Is it preface? Okay, or is it postface? So if it is preface, we know that we should do the addition or subtraction before any other thing. So we are going to add or subtract before we do any other thing. So in our case where we're just printing, if it is preface, then it means we are going to add or subtract before we print. But if it is postface, then we are going to do the action. So do whatever you need to do before you do your add or subtract. So in our case, since we are printing, if it is postface, then we are going to print before we add or subtract the 4 bytes. I hope that makes sense. Okay, so where is that one? Let's go ahead and print this. And we can see that this is giving us the original here. Okay, this is giving us the original here. I want to copy this line and do this. Now somebody should tell me, what should I expect for this line? There's a lot of people here, but you are not talking. Kindly unmute and speak. Let me know
It's just
how you also get in it.
it's just the address.
Yes, come again.
It's just the address. It's just the address.
Which of the addresses? So now we are having about,
Line 17.
is it going to change? Is it going to be the original address of the pointer? Or is it going to change? That's what we are interested in. Always remember that your program
The new one will be printed. That's the X0 will be printed.
Okay, so relax. Now I have 3 people. Relax. I have 3 people to point to right now: Ima, Joe, and Chiquito. I'm going to point to you right now, but let me make this comment. So we have, always remember that your program reads from top to bottom. And as soon as something is read, if there needs to be a space allocated, your computer will automatically allocate space and save the thing. So by the time you go to the next step, if you already have something in memory, then it's going to use what it has in its current memory. Okay, so that's what I want you to pay attention to. All right, Tikito, let's listen to you. What were you saying?
Okay, since increment has happened now, that means the new value will now be the new address. That's the one that ends with 80. That's what will be printed now.
Okay, but line 16 would print the original, but line 17 will print the new. Is that what you're saying?
Yes.
Okay. All right, Joe, let's listen to you.
Okay, for me, I tend to agree with what Chiquito has said.
Okay.
For line 16, it will print the original address, but for line 17, it will print the new address. That is the original address plus 4 bytes.
Okay. So I think it's similar to what she actually said, if I understood it right. That's similar to what she said.
Yes,
okay. All right. Yes, you do.
Hello.
Yeah.
Yeah. What we this value PTX++, it will actually go ahead and print like you said, precedence is to take note of the address, and then that's what will print first.
Okay.
Yes. So in this case, actually, the 17 will also do the same thing. We'll give you the position, the address of PTX. He's not taking consideration of what happens to number 16. That's what I'm trying to say here now. It's not taking consideration of what happened in number 16. So I don't know. Yeah.
All right. Let me take Ima. Ima, what were you saying?
No, it's just the same thing that Chiquito said. That was what I was trying to point out.
The same thing that Chiquito said?
Yeah.
Oh, okay. That's okay. Any other opinion?
Okay. I tend to go with I think Joe and I think the first lady. I think the line 16 is going to print the original, but then it's going to take note that the PTX has been incremented. So the next line you're going to print is just going to print out the incremented value. So line 16 is going to print the original value, while line 17 is going to print out the new value now. That's with the 4 bytes.
Okay. Just noted. All right. So if any other person has a different opinion, let's take that one before I comment on it. A different opinion. All right, good. So that's why before we started, I mentioned the fact that our C program or the compiler will read our code from top to bottom. And anywhere that there is a demand for storage, is going to create that space and store that. Okay. So what is happening here is that when we start our program right from the top, we have X being assigned to 10. So your computer will create that storage in its memory and store X to be 10. So we get an address. And now we can pass the address of X to a pointer. In our case, we are calling it PTX. So we've passed the address here. Then when we come down here, we are printing the address that we kept in here. That's what we are printing. Then the next line was printing 1. The next one was adding 1. That is one integer. So we all understand that that is 4 bytes that we are adding to the original address of PTS, or the original address that PTS is pointing to. That we have already understood. Now we are coming to the use of increment and decrement. And we realize that to print this PTS plus plus, we now know that plus plus has less precedence. For that matter, we go ahead to print this. So our computer will print the PTS, that's the actual address that it points to, even before it does the increment. But it should remember that this, I keep saying that because of the plus plus, is going to occur in 2 steps. So the first step is the print. Then after it has finished with the printing, that is what you are going to see. You have seen that it has printed. But after it has printed, it's going to do the increment. So the new value of PTS is the one that we have added 4 to. Because after printing, there was an increment. Remember, when we write this, it's a bit different from this expression. The reason is that when you write PTXX, the plus plus means that we now have a new value. So it is this. PTX is equal to PTX plus 1. Over here, we didn't assign this new value to the old value of PTS. Okay, but here when we are doing an increment, we are going to reassign PTS. So we are giving a new value to PTS. But before we did that, we had already printed out PTS. So in that line 16 is not going to print the new value. But anything beyond line 16, our PTS has changed. So that is going to happen here. Now that we are printing PTS, there is a new value of PTS. So when we go ahead and print it, we would have added 4 to the original PTS address. Does that make sense?
Yeah, it does.
Yes. Okay.
So may I say something?
Yeah.
So,
okay.
Yeah, in this case, now we are not talking of 17 again. 17 is clear. Now I'm asking, is 13, line 13 and 16 the same thing, or
they are not the same thing?
They are not the same. Okay.
They are not the same thing. The reason being that when you use plus plus, it means you are reassigning the thing. Here we are just adding 4 bytes because it's an address. We are just adding 4 bytes to it. But we are not saying that after adding 4 bytes, assign that value to PTS again. But when you do increment, the thing is, I think you people still haven't gotten this concept. The thing is, when you see something like this, A plus plus, this is a whole expression on its own. I mean, a whole equation on its own. It means A is equal to A plus 1. So it's a whole equation. This is different from just writing an expression A plus 1. That's what is happening. That is why we need to do it in 2 steps. So this is actually an equation on its own. So if I come and I write y is equal to x plus plus, what I'm actually saying right now is that y is equal to x, this, then x is equal to x plus 1. 2 steps. So when you are seeing this, this is what it means. Y is equal to x, then x is equal to x plus 1. When I say y is equal to plus plus x, what it actually means is that I have x is equal to x plus 1, then y is equal to x. But now this x is a new x, so y is equal to the new x. So just remember this. Anytime you see plus plus, it's a whole equation. It means that whatever variable you are dealing with is equal to the old value of that variable plus 1. So it's a whole equation on its own. Do we get the concept? Do you get the concept? Please. Oh, let's talk. Let me know. Now let's use decrements. So all that I have said in summary, is that minus minus means that, so let's say minus minus x. This is a whole equation. It's an equation. Okay, at least remember what they taught us in primary school mathematics. An equation means it has an equal sign. In our case, it's an assignment sign. So x is equal to x minus 1. This means that the x here is the old value of x, and this will become the new value of x. So if you have an expression that says that y is equal to minus minus x, what this actually means is that this is two equations put together. That's what I need you to understand. Once you have seen this, it is two equations put together. But the question is, which of the equations should be evaluated first? And once the minus minus is coming before your variable name, it means that evaluate this equation first. Okay, before you go to the next equation. But if it was, so if it was the other way, where we have y, let's say y is equal to x minus minus, then we'll have the first equation will now become y is equal to x. Then x is equal to x minus 1. Please, I don't think this should be difficult to understand. Okay, I said in primary school they told us 1 plus 1 is equal to 2. And ever since then, we have all kept it in our head. 1 plus 1 is equal to 2. So that's what I want you to do right now. Y is equal to minus minus has to be done anytime you see minus minus x. Come again. Yes, higher precedence. Thank you. So whether you check whether it is before or after. If it is before, then that should be done before the next line. If it is after, then that should come after the first line has been executed. Okay. Any questions? So instead of doing plus plus here, we want to do plus plus this way. Or this time around, let me change it to minus. Minus minus. Someone should explain what is going to happen in their own words. Let me comment outline 17. So in your own words, interpret line 16. Hurry up. We'll be closing soon, so let's hurry up with it. In your own words, interpret line.
I want to ask question.
Goodness.
Did we conclude?
Okay, Ima.
Yeah, did we conclude that the previous example that you gave, not this present one, did we conclude that line 16 and 17 are the same thing?
No, they weren't the same. Line 16 was printing the original value. Line 17 was printing the new value.
Okay.
Yes.
Okay, so for line 16, and with the decrement value before x, it would subtract 1 from x before printing the address.
Thank you. All right, so line 16 in this case, we are going to have the subtraction of 4 bytes before the printing. Okay, because we have put the minus minus in front of it. So what if I now go ahead and uncomment line 17? What will line 17 be?
It will give the new value after it has been after 4 bytes has been deducted from x.
So will 16 and 17 be any different?
They will be different. They will be the same, rather. They will be the same. 16 and 17 in this case will be the same.
Okay. So they are going to be the same because this print statement will wait for the subtraction to be done before it prints it out. And this is just printing whatever the current value of PTS is. So it will take its value from what we got from this and print it out.
Okay. Please. Okay, good day.
Yes,
My name is Saman.
Yes. Paul.
Please, I want to know what happens to the variable, the value of the variable that pointer is pointing to. I mean, this is us tampering with the address. So what happens to the actual value?
Okay.
Does it move like the new address? Just like that.
Okay. Yes. All right. I get your point. So I think at one point I was trying to explain this. Someone asked a similar question. I was trying to explain this with this diagram. So all you should know is that so far what we have done is just adding or subtracting from address. We've not touched the value. And anytime you add or subtract from the address, you are just looking for another location. That is all you are doing. So if, let's say, this address is what we are subtracting 4 bytes from, we are just moving backwards to this grid where we don't know what is there. Probably there is something there that we will need. Okay, so your addition and your subtraction doesn't affect the specific storage, that address that you are adding or subtracting from. It doesn't affect it. All that you are doing, for in our case, let's say pointer, what we're using, pointer x, so ptx, x is equal to 10. So let's go back to this. Let's assume that this is where we have s is equal to 10.
Excuse me, sir.
Yeah.
Please. Okay, you're about to do it. I want you to use an actual value and do it.
Yes.
The actual value you have
so, yes, I'm coming to do that. Okay, so now we know that pointer x is actually pointing to this location. Okay, this location. And let's assume that this ends in 84. So the address is a hexadecimal that ends in 84 for this specific location. Okay, so if you go ahead and do -1 of the pointer, -1. So let's say I do, let's say pts minus. What I have done right now is that I have reassigned the location of pts. So pts will no longer point to this location, but rather this location, because I've come back 4 bytes. So I've just changed the location of pts. So if there was a value already here, say we're storing 25 here, if there was, then now the value of this becomes 25. Or now that I have pts being a different location, I can give a new value to this. If it was an addition, it would have moved me in this direction. So what I need you to remember is whenever you add or subtract from a pointer, that's the address, all you are doing is that you are moving to a different location. Whether you are moving forward or backwards depends on whether you did addition or subtraction. So you move forward when you add. It has nothing to do with the actual value that was there, unless you decide to dereference it and get the value. But now you can move. And when we get to arrays, we will understand why we need to be moving like this. So last 2 days, somebody asked me to explain tax 10 that we did in the previous, I think, Friday session, tax. And you realize that in tax 10, we're using pointers to get the value or change the value of an array. So let's assume that after x was here, let's assume that here contained a variable called y, and y was equal to 5. Okay, and this address ending with 84 means that this y location will be ending with 88. So if I now decide that my pointer that was pointing here, let me add 1 to it and turn it to the new pointer. So that is doing an increment. This new pointer will now point to this location. So if I dereference this pts, I'm rather going to get 5, not 10, because now it's pointing in this direction. Very important. The last thing that we are going to do before we end is how to operate on the values themselves. But you need to understand how to operate on the addresses. So in summary, when you add or subtract from the address, you are just moving a location forward or backwards. When you add or subtract, respectively, you are moving either forward or backwards. Add is forward, backwards is subtraction. Okay, and it depends on how many bytes you are moving backwards. If you go there, now you know the location. So if I decide to move, let's say, this is 4, 8, 12. So if I decide to move 12 bytes, that subtracts 3 from this, I'm going to land in this specific address. So if there is nothing here, I can decide to come and put a new value here. I can decide to, if there was an original value here, I can decide to do other things with that value. Or I can go and grab the value there and come and use it. By adding or subtracting, we are able to get the values that are stored at various locations in the memory of our computer. When we begin to work with arrays, then we will understand this, because in arrays, these variables that, or the numbers or values that make up the array, are in a continuous order. So we can have, if we have an array that is made up of 1, 2, 3, 4, we can have the array being stored as 1, 2, 3, 4. So if I give you this specific address and I ask you to add 4 bytes, in that case, increment that pointer, then it's going to land you here, meaning now you have access to the value here. That is how it works. Yes, are you answered? Top man Paul, are you answered?
Thank you very much. Yes, sir.
You're welcome. Yes, any other question? Any other question? Hopefully now we all understand how we work with the addresses. So let me quickly touch on the values themselves. So the values, working the values isn't any different from what we have already done, except that this time around, we know specifically that we are looking for the values themselves. So instead of using the P format specifier, we are going to be using D for integers, and we'll dereference our pointer. So now, I want to challenge somebody's thoughts. Line 19, if I print line 19, what outcome am I going to get? If I print line 19,
you get
come
10.
again.
You get 10.
Do you agree? Joe, what did you say?
You will get 10, which is the value that is stored to the variable that is being pointed to.
Okay. Any other person who disagrees?
I disagree.
Okay.
Based on the answer you gave right now.
Okay. I'm glad you understood your question. Thank you. So that is what Topman was saying. Based on the answer I gave to his question earlier, he disagrees that they should point to 10. Because before we got here, you have done a decrement here. You have changed the location. See what is printing for you. This is what is printing for you. So that means that when it got to that specific location in my computer's memory, this was the value that was stored there. And you and I didn't store that value. Okay? So always in C programming, always you have to be mindful. Never presume that your memory is empty. That specific location that we're going, it could have been empty. But unfortunately, there's actually a number there, so it printed that number for us. And the reason why that is so is because we had only assigned a value to this pointer, this address. That's where this value was, the address that this was pointing to. But when you did a decrement here, you have moved to a different location, 4 bytes before that specific location where you kept your 10. So it's just going to that location and looking for what is there and printing it out for you. If, however, we decide to comment this decrement out, then run, then it should give us 10. Because now we haven't changed the location. We are looking specifically at this particular location. If I should go ahead and do an increment and run, it gives me a different value because we are in a different location. Does that make sense? So I hope this clarifies, Topman, your question that you asked. This should clarify it. Yes, Haruna.
So when you are moving to a different address, the value in the initial address doesn't move with you.
No, it doesn't move with it.
You get
It's still in that address. That's
okay,
why I
that's
kept
what I
saying
wanted to
that.
know.
Yes. So I kept saying that when you add or subtract an address, it's just you moving to a different location. The original address is there. Please, if right now where I stay is not where I am right now, it doesn't mean my address has changed. I just moved to a new location here. But when you go to where I stay, my things are there. You get it? So you don't take the value with you. All that you have done is just to help you move to a different location. I'm telling you that this will become more practical when we are dealing with arrays. Because with arrays, we have a lot of elements in adjacent locations. So when I'm moving backwards 4 bytes, I know there is an element that I'm looking for. When I'm moving for 1 bit or 1 byte, I know what I'm looking for. Okay, so I hope that answers our questions. Any other question? Otherwise, let me try ending it with the tax 10 that we talked about the last time, which was, if only I can remember again, it was, we were given an integer n, then an integer, no, an array a, and the array had, was it 100 members? Then a pointer p, and we're given a2 to
I
be,
think the array was 10, either 10 or 5.
it was 10. Okay, whatever it is, it
It was 5.
will still work. It was 5. Okay, so let's use 5. Okay, then our pointer was pointing to address of n. Okay, and we're to write a new line of code that will now make the second member or array with index 2, the index 2 of the array A, to be equal to 98, right? So this was one tricky question. Excuse me. This was one tricky question, which I could only arrive at an answer by doing try and error. Because there is no relationship between A and N. But you need to find a relationship between them before you can solve this question. Because they've told you not to manipulate A. That's the thing they gave us. If they didn't tell us not to manipulate A, you can just go ahead and say reassign A and say A of 2 is equal to this, or use the address of A. Then maybe you point a pointer to A, then you dereference that and change the value. Okay, but we've been told that we can't touch A. So if we can't touch A, then what we have to do is work with P. But P, as we know here, is pointing to the location for N. It's pointing to the location for N. So what I decided to do is, after declaring this and declaring this, let's find the address for each of them and see if there is a relationship between the two. Please give me a few seconds. Let me close my window. It started raining, please. Okay, so let's continue. I'm trying to find a relationship between N and the array A. That is the only way I can. Or that's the only way I'll be able to manipulate A using the pointer to N. Okay, so that's what we're trying to do. So for that matter, I decided to print out the addresses between of these two and see if there was a relationship. Because before this particular task, I didn't know that automatically declaring two variables or one variable and one array, there could be a relationship between their location. So I was just trying to see, and I ran this code, just print the addresses, or let's say address of A, then N. So that's the first one, address of N. We can do that by passing the pointer P, because we know P points to the address of A. Then address of the array. So one thing that you should know here, in our next POD session, we are going to discuss arrays. Okay, the practical usage of arrays. We have actually discussed arrays, what they mean, when to use them, why we need to use them in the last session, which is already available. So you can watch it before our next session. The next session, we are going to do the practical session, where just like we did today for pointers, we are going to be doing it for arrays. Okay, so hopefully we'll get to understand that. But what we need to know is that for arrays, okay, this array that we are dealing with, A of this, when you get to the name of the array is actually a pointer to the array. I've explained, let me quickly jump there. I've explained that this 1, 2, 3, 4, if it was in this array, okay, the name of the array usually points to index 0 of the array. So if this was array A, whenever I call A is actually a pointer to this address. So that is one more reason why we needed to understand pointers and what they mean. When I call A, it's actually a pointer to index 0. Okay, so that is why in here I can just call A here by not going to declare any pointer to the array. Just by calling A will give me the address of this array. So let's go ahead and run it. Oh, where are you? I've already declared integer, so I don't need it here. Okay, so this is address of N, and this is address of A. And I realize that the difference is 6 bytes. Okay, so when I realized the difference was 6 bytes, initially, when it was the first time I was running it, I was presuming that it just happens that it was 6 bytes. But after running it a number of times, I realized that each of them was 6 bytes. And even when I change the name of the arrays, I change the name of the variables that I'm working with. Say this now is X, and this is, which one? Y. So we'll have Y here, right? Change this to X. Even after changing the variables, it's still X. Okay, oh, I've changed the array to Y. Okay, so the difference is still 6 bytes. This means that it is consistent, or it's a constant difference. After initiating a variable, if the next thing that you initiate is an array, your computer will automatically leave 6 bytes before the array. Okay, this means that now that I know that automatically my computer is going to leave 6 bytes before I get to the index 0 of my array. If I want to go and change the index 2 of this array, all I need to do is to add the extra byte to get 2. Then now, once I have found the address of 2, I can manipulate the address of 2 to get the value changed. Okay, so what I decided to do was, okay, let me just start, because I said that it was the first time I was encountering something like this. So I just did try and error. I just add in 4 bytes, 4 bytes, 4 bytes, and see if I will get to the second index. So what I'm interested in right now is, let me get what's the, let me copy this first. Or maybe I should change them back to the parameters that we were given so that I don't end up confusing anyone. Okay. this was A, right? So this is A, this is N, and this is A. Okay, so what I'm interested in printing right now, for that matter, I'll go ahead and comment these two lines out, is the address of the index 2. The moment you bring this, you need to introduce the address sign, okay? So that's what I'm interested in right now. Oh, X, where are you? I should change it to N. Okay, so something like this, okay? Obviously, when we run it again, it will change. But now I know that address of 2, this is the second index 2. Address of index 2 is something like this, okay? So I need my P to point the new P, like I need P to help me point in that direction. So what I'll do is say, let me just try printing. Let me take this line and reprint it for us. Oh, I need them to give me the same value, the same address. Once I get the same address using just P, I'll be able to manipulate it. So I start by doing P plus 1. P plus 1, because we are working with integers, means that I'm adding 4 bytes. Hopefully by now, you all know that, okay? So this is not necessarily address of N, but because we are using P, which is pointing up to N, so let me say N asterisk, we are changing it. So by printing this, let's see what we get. There's still some difference. This is 10 difference, 10 bytes. So let me go ahead and increase it, different 10 bytes. Let me go ahead and increase it by say 2. It's still not the same. Okay, so I tried 3. That's the actual process I went through. So I tried 3, difference of 8. If difference of 8, then if I add an extra 2, that would be 4 bytes. So let's put 5 instead. When I ran it with 5, the magic happened. Now we have the same address for this and that. This means that for my P, the address here, if I add 5 to it, I get the same address as this. If we go ahead and print the value of A2, let's print the value of A2 here. We are looking for value, so decimal, and print A2. A2 is currently 1028. So say value of this. So if I use this line as well and I do value of, you know that now because we have added 5, we are pointing to that specific location. So if I go and find value of this new location that we are working with, it should give me 2. But to get the value, we need to dereference it. Dereference it by putting the asterisk here and run it. And we get 1028, 1028. So with the help of the address that we were given, we are able to now go to that specific location where this index is found. Once we know that this will give us the value, we can now go and change the value. Say before we print the values, let's change the value to, we are now going to do a reassignment. Say P plus 5 is now equal to 98. Once we have reassigned the value that is supposed to be in this location, it means it will no longer be 1028. So when we run this, we get 98 because we have reassigned it. So that was what the program was asking us to do. Just add this line of code to whatever they gave us, and that will print out the value. Okay, but if you have never encountered this before, I think this is where newcomers or people who are totally new to programming are killing themselves over these things, because you seem not to figure out these things, like you are lost. Please, let me tell you this, we are all lost. And that's the reality of every software engineer. Almost every program that you are going to meet may be a new problem. Almost every problem that you are going to meet may be a new problem. If you are fortunate enough and it's an old problem, you will know how to solve it. If it is not an old problem, you don't know how to solve it. You would have to reason by combining some knowledge that you have. But it's not all the problems that look familiar that you can just combine. Sometimes you have to go and ask, talk to colleagues, discuss, ask, Stack Overflow, go and check what other people have already complained about. Put one or two together before you come to conclusion about a solution. So even with this, I didn't just get up and say, let me test this. I didn't know where to begin. So we'll still definitely have to go reading around. So you try breaking the problem down. There should be a relationship. That's how I wish I had recorded the process of me doing those searches. I was trying to find out if there was a relationship between when declaring a variable and declaring an array right after declaring a variable, whether there was a relationship between them in terms of their addresses and the likes. Okay, so please and please again, if you're new to programming, I am pleading with you. The fact that you couldn't solve the problem doesn't mean that you don't know it. Everybody has that problem. The people who were able to solve it are usually the people who have come across it before or have come across something similar before. And always remember that in this group that we find ourselves, in this program we find ourselves, we all have different level of experiences. Very important. Don't necessarily compare yourself to others. But right now that you have seen this problem, if you meet it tomorrow, will you be able to solve it? That is all that is important now. Now you've seen this problem, you've seen how we went about solving the problem. If you meet it tomorrow, will you be able to solve it? Okay? And if something else, not necessarily this problem, but something that demands a similar thing, will you be able to use the same thought process to solve it? That is all that is important. So please and please again, let's pay attention to that. On that note, I think the last set of exercise that we did yesterday before we left, and last 2 days before we left, let's do that same exercise where we need you to interpret some things. Okay, need you to interpret some things. Let me get, I think it was a screenshot I took. Get that screenshot. Good. Yes, so the first question was this, which we have already, if we had a pointer p and we had p plus plus, okay, say we assign y is equal to p plus plus. Somebody should, okay, I think I gave an example where p was pointing to a variable, say x equal to 5, and p was a pointer to that variable, okay. So I would need to say p is equal to address of x. In this our case, what will y be equal to and what will p be equal to? Okay, that's what I need you to tell us. Assuming that p points to an address that ends in 84. Yeah, someone should unmute and explain to us line 8. What do you think about line 8? Line 8, what would the value of y be and what would the value of p be? Yes. So there are a lot of people here. Anyone? If no one speaks, then we are closing. This is the last bit. Yes, Mike.
Okay. Y is equals to, I think p plus plus, right?
Yeah.
I think the value of y will be the original value of p.
Okay, which is?
While the value of p will be incremented.
Okay. So give us the original value of p.
Okay, is p 84 here?
Hey, sorry, I'm coming. Let me do this. I meant the original value of the y, that the value that you assign to y right now. That's what I was looking for. So we are looking for 3 things here, I think. Yes. So y will be equal to what? That's what I'm looking for right now. You have explained it, but I want you to mention it. Yes, Michael.
Okay, the value of y here will be 84. I think y is going to take on the value of p.
Where the value of p, so is it the actual value or the address? Because this dot 84 is representing the address.
No, I think it has been dereferenced. Star p plus plus means the actual value, not the address now.
So what is y equal to?
Y would be the value of x, that is 5.
Okay, thank you. So y should be 5 in our case. Then
Yes.
what would be asterisk p?
The asterisk p would be 6.
Okay. Then p itself.
I think nothing changes about p.
Okay. Do we all agree? Please, I want people who disagree with me. Michael, thank you. Okay, you agree with him. Anyone who disagrees? Yes.
Mine is actually not disagreement, it's just that I don't understand where y is equals to 5.
Okay. Did you join late?
Yes, I joined late.
Okay. All right. So anyway, the lesson will be made available. Yeah, Abraham.
Available today or tomorrow?
I'll try my best to upload it today, then send the link around. So hopefully you get it.
All right, thank you.
All right, can I ask?
Okay,
Yes,
for me,
Abraham.
I have an observation. For in line
Okay.
7, is it correct to say int asterisk p is equal to the address of x, or should we say int p is equal to the address of x? Should it be with the asterisk?
Yes, it should be because we are now declaring the pointer. Okay. So what this can actually be expressed in two forms. This way, or the other way would have been for us to just say, so let's assume I commented this out. It would have been for us to say int asterisk p this before we now come say p is equal to then address of x. So this is one way that we could have done it, okay? But we can equally put it together by just taking away this p, then this.
Okay, thank you. I get you now.
You are welcome.
Right. So I just observed something. You said asterisk people. All right. If I should understand that, it's doing the arithmetic before it's the reference, right?
I'm struggling to hear you. Sorry, Abraham.
It said if I can observe clearly. Can you hear me?
Yeah, I can hear you now.
I can observe clearly. I'm seeing asterisk p plus plus. That means it's doing the test before it's dereferencing, right?
During the what? It's doing the what?
Arithmetic. That is doing the adding first before it's dereferencing.
Are you sure? That shouldn't be the case.
You're moving a pointer and getting the values, right? You're trying to move the pointer to the next address, and you're trying to dereference it and get the value. Is that not what the asterisk?
So this is the case of precedence, operator precedence. Okay. So in this specific case, the asterisk has the dereferencing operator has highest precedence over all of these. So please let's go and learn or read on the operator precedence. Okay. This particular asterisk here has the highest precedence among these ones. For that matter, we are going to have this dereferenced even before assignment. Then after assignment, before we even have this plus that. Very important. So I broke it down when we were doing those things. Once the plus plus is after this, it is the least. If this plus plus was before, then it's a different story that we are talking about. Once it is after, it is the least when in terms of their precedence, okay? So we would need to dereference this and assign the dereference value to y. After assigning the dereference value to y, we'll now have this dereference value incremented because of this plus plus. So that is what is happening. Are we clear on that? Any questions?
I think so.
Okay. All right, sure. So let's look at the next expression. The next expression is y is equal to asterisk plus plus p. So we need to know what y will be equal to, then we need to know what p will be equal to, then we need to know what asterisk p will be equal to. Just explain. These are not like very practical things that I'm doing right now. I just want you to understand the precedence in this case. Then we end our session. Okay, so explain what you think this would mean or what will happen here. Yes.
Okay, what you just explained just now, it means that dereferencing is going to happen first, and it's going to
which one is going to happen first?
Dereferencing. That is the asterisk is going to win out. Is going to win based on the evidence you just measured. So
remember that this is not the same as this, because this is postface, this is preface. They are two different things, and each of them has their own precedence.
Okay.
When it comes before, it has a higher precedence than when it comes after. Very important.
I think that's why I'm messing it up. All right, just go on.
Okay. Any other person?
Okay. So what
Okay, let's
I'm
listen to. All right, Michael, continue.
Okay, what I'm seeing here is we are dereferencing and incrementing p first.
So what will happen first? Those are two different things that you've talked about. So what will happen first?
The increment is going to come first because the incrementing symbol is a prefix here, not a prefix.
Okay,
so we are
please pay attention because it is the how do you call it? Preface. It's something like this. This is actually what is happening. So the bracket will occur first. That is, this will take place. The increment will take place. Then the reference before assignment.
Yes.
So in that case, if we increment p, what are we actually doing? Which of these does it affect? Is it this, or this? Which of them does it affect if we increment p in this sense? What does it mean? Plus plus p, what does it mean?
It is incrementing the address.
The address.
Yes. Thank you. Yes. So the address that p is pointing to, we are now adding 4 bytes to it. That's what we are doing here. So p here will now become 88. This means that when you devalue it, sorry, did I say devalue? When you dereference it, we are actually going for the value that exists in this location. So if nothing exists in that location, then we are not going to get anything. Otherwise, we will get something else. That's why I can't be printing out what we are doing right now. Okay, because we haven't created values for them. All I need you to know, please, for those of you who don't understand, just keep this in your mind. Okay. The moment that this was after it, it became the least. When it came in front, it became the highest. Okay, so when it is preface, it's like the highest. When it is post, it is the least. So kindly keep that in your mind. Any questions? Yes, any questions? Okay. This is where another confusion is likely to come. But please, please, and please again, don't confuse this. So that's why I'm giving you all the possible scenarios so that you get it from here. If you don't even go and read on operator precedence, at least use, there are 4 of them that I'm going to give you. I've given you 3 so far. Okay, this is the 3rd one. So let's keep them the way they are. Anywhere you meet them, this is how it means. This is what it means. Okay, so just keep that in your head. And better still, when you read on operator precedence, you will understand them. Do you think this is the same as this? If not, explain what you think this will be. If yes, to explain.
I don't think they are the same. Why 10 and 11 are not the same. 11 is referring
Okay.
now to the referenced P now. So the increment
Okay.
will happen such that Y will be 6, and
Okay.
the new P will still be 6, and the address will still be the same as the last one, which is
Okay.
88.
Okay. All right. So just as she has explained, this one, I put the brackets here to simplify it for us. In this case, the brackets will be here. Okay. So this is what this expression actually means, where we are actually dereferencing P before we are doing any other thing. So once we have dereferenced P, we now have the actual value, which is 5. Then plus 1 to it becomes 6 before we assign 6 to Y. So meaning in this case, our Y will be equal to 6. Our P, which is the address, we haven't done anything to the address. So our address will still remain as 84. Then the reference P, we have already added 1 to it. So the reference P now becomes 6. Any questions? If you don't understand, just keep it in your head, please. At least don't even worry about the equal to parts. All that is important right now is understanding these expressions. Let me remove the brackets. So please, if you didn't take notes today, just take note of this thing. Just this part. Okay, this and what it means, this and what it means, and this and what it means. Okay, last one. The last one
Wait,
is
I have a question.
yes, ask your question.
Because this thing is following the order of execution, why on 10 change the address there? So why are you
On
still
10.
maintaining 84?
No. Please, I'm not executing this program. Okay, sorry.
Okay,
I'm
I
not
want to
executing
comment
this
it
program.
out because I
Yes.
read it that way with you not commenting it
Oh,
out. I used the last
sorry.
address.
Sorry. I beg.
Okay, no
So,
problem.
what's happening is that's why I said this is no more. It's not very practical. I'm just trying to explain these things. Okay, how the referencing and the increments and decrements come together. Okay, because that's what worry a lot of people. That's why I'm putting these things here. Okay, so now let's look at the last one. What's happening here? Yeah, you're even fortunate. I've brought the bracket for you already. Once I've brought the brackets, I've exposed it already. So someone should help us so that we can end our session today. Yes, the last line 12. What's going to happen?
I think
Yes.
Y will remain the same.
What remain the same is what? Y is equal to what?
Y is going to be 5.
Okay, 5.
Then we are still on the same address.
Okay.
Then the referenced one will add 1. That should be 6.
Do we agree to it? This line actually is not different from this. It's not different. Come again, Michael.
So I wanted to ask if there is any difference between line 9 and 12.
Oh, so there's no difference. Okay, so hopefully this explains what we needed to know about pointers. And when we start arrays in our next POD session, we'll get to see why these are important. At least I've tried illustrating some of them here today. And also, when we are doing functions, I think I should have even done a function example. So hopefully, in the next POD session, before I jump to arrays, we'll take pointers in functions to explain something before we get to the arrays themselves. Okay, I checked the calendar for ALX yesterday, and we are supposed to have a POD on Tuesday and Friday. Tuesday's POD is supposed to be on arrays and pointers as usual. Then Friday's POD will be on what we will learn on Wednesday and Thursday, which is recursion. But unfortunately, I'll be on the road on Tuesday. I'll be traveling back to where I came from. That will be on Tuesday. So I doubt I won't be able to host the POD on Tuesday. For that matter, what I am suggesting, I discussed with my colleague who was here. What I'm suggesting, which I'll put the details in the group soon, is that we may postpone Tuesday's POD to Friday. Hopefully Friday I'll be home. So Friday, then we'll do Friday's POD on Saturday. Would that be okay? So we'll do arrays and pointers, the final one on Friday. Then Saturday we'll do recursion. Is that okay? Otherwise, if you have other opinions, you can suggest it in the group so that we'll end the session. It's actually too long already. We have 2 hours, 41 minutes. So just to mention, if you have any suggestions regarding our POD, just suggest it in the group, okay? I'll respond to that. But if you have a specific question in the next 1 minute, let's finish it and end the session. Yes.
No, I think your
Yes.
suggestion is okay. That was what I wanted to confirm.
All right, that's fine. All right, so thank you all for joining today's session. I'm glad we're able to record it, and hopefully I'll upload it and share the link soon. Thank you, and I'll see you the next time. Bye-bye.
Bye-bye.
Thanks.
Thank you,
Thanks,
Doc.
Dr.
Bye.
Welcome.
Thanks.
Thank you so much.
You're welcome.